Hello students, warm welcome to video learning lecture. My name is Aashish Gohel. I'll be teaching you some other questions of differentiation from NCERT textbook. Today we will be solving questions from exercise 5.4. So which type of questions are given in exercise 5.4? Will be given questions of exponential function. Okay, first thing, what is exponential function? Exponential function is a function in which in power you will be given term containing x. Yes, either you can say e raised to x, e raised to root x, a raised to x, e raised to sin x. All these type of functions are said to be exponential function, in which you will be given x or any function of x in the power. Exponential means we understood that e raised to, but e is some special number. The value of e is 2.718, such that any number raised to x also can be an exponential function. But in our textbook of NCERT, we are given the terms containing e only. Okay, so here basic concept of exponential function, that is e raised to x into e raised to y is raised to x plus y, e raised to x divided by e raised to y is equal to e raised to x minus y. Okay, this we need to remember. Other than this thing, what we need to remember to solve this exercise? Basic rules of differentiation, that is product rule, division rule, and main important is chain rule. Let us solve one question or two questions of similar type to understand this exercise. One of the question is given like this: e raised to sin x divided by x. So we want answer of dy by dx of the same question. So what we will do? So first thing we need to apply is division rule. Okay, so according to division rule, upon square, upon term as it is differentiation of numerator minus numerator as it is differentiation of denominator. Okay, so x. Now how will we differentiate this function? We know that differentiation of e raised to x is e raised to x only. So here differentiation will be e raised to sin x, but again I need to differentiate sin x according to chain rule. Okay, because as per chain rule, in place of x, if any another function is given, then that second function will be differentiated second time. Okay, so the answer of d by dx of e raised to sin x will be e raised to sin x into cos x minus e raised to sin x, here answer will be 1 divided by x square, and this will be your final answer of dy by dx. Understood? So here we have applied two rules of differentiation, that is division rule as well as chain rule. Okay, let us try another question of similar type, that is of exponential function differentiation. So here we will take one more question, that is square root of e raised to root x. Now here I can simplify this e raised to root x whole raised to 1 by 2. Okay, now as per chain rule, d by dx of f of x raised to n is n f of x raised to n minus 1, and again differentiation of f of x. So this rule will apply over here. Here f of x is this term. Okay, now if I differentiate this, then power will be ahead, one power will decrease, so power is 1 by 2, one power will decrease, so 1 by 2 minus 1, and again we differentiate e raised to root x. Okay, so 1 by 2 e raised to root x, 1 by 2 minus 1 will be minus 1 by 2, then differentiation of e raised to root x. Again we need to apply chain rule over here. Differentiation of e raised to f of x is e raised to f of x only, and again differentiation of root x. Now we need to remember differentiation of root x is 1 upon 2 root x. That we can put directly over here. So the last answer will be 1 by 2 e raised to root x raised to minus 1 by 2 e raised to root x as it is. Okay, then differentiation of this term is 2 root x. Now you can do one thing over here, that here raised to minus 1 by 2 is there, here root x is there, so you can merge these two terms. Okay, here power is 1, here power is minus 1 by 2, you can merge these two questions. Okay, and that will be your final answer. So this is all about exercise 5.4. All the questions are given in this format only. We just need to apply product rule, division rule, and main importantly chain rule. So stay tuned, stay connected for more videos like this. Thank you so much.